Hello. So we are doing, I think I'm right up here, 6.2, law of cosines. So the way that this is going to be different from law of sines is in law of sine, we were only able to use that if we had a matching pair, specifically a matching pair of angle to corresponding side length. So if we had an angle measure A with a side length A, we could use law of sine. And it didn't matter what other third measurement we had, we could use law of sine. If we had an angle measure B and a side length B, an angle measure C and a side length C, if we had those two measurements known, we were able to use law of sine. When we don't have those two measurements known, there was nothing else that we could use, so we just weren't able to solve the triangle. At this point now, with law of cosine, that gives us that opportunity to actually solve those triangles when we don't have a matching ratio. So if you remember, law of sine was like you took the sine A over A, or A over sine A. So they were pretty simple, I'd say, pretty simple formula to remember. One formula and its reciprocal, and then that was it. Super easy to pump out and remember and use, and not a complicated formula whatsoever. Kind of hard to mess up on when you were putting it into your calculator. Hard to remember any of that formula wrong too. So we like law of sine, and we usually try to use that more often than not. It's not that law of cosine is difficult, but when looking up here at all of these different formulas, let me move this over just a little bit so you can see that one. When looking up here with all these different formulas, there's a lot going on here. There's lots of different addition and squares and subtraction signs, and a lot of different places that you could have errors. Not only that, but they're harder probably to memorize than the law of sine formula, and there's a lot more of it. These are just a little bit more complex, more complicated, more to them. They look a little gross, they look a little ridiculous, but they're essentially just as easy to use. They just look a lot worse. With the memorization fact, law of sine is much easier. Taking out the memorization fact, they're both equally as hard or easy. And truthfully, sometimes I think law of cosine is even just a little bit easier in that regard, because it really is just a plug and chug. There's not much solving that you have to do. So you will notice a pattern when you're going through these formulas. That being, these are all your side lengths for one. So if you are ever trying to solve for a side length, you will use one of these three formulas, depending on which one you're trying to solve for. But you have to know the other two side lengths and that corresponding angle measure. If you don't have that, you're not able to use this formula. But if you kind of go through these, you can see a huge pattern. We want to know A, so we use BC, BC, and then cosine A. We want to know B, we use AC, AC, cosine B, and so on. So if you know one of these, you could essentially know all 6 of them. You could create all 6 of them. When we're coming over here to these formulas, these are all being used if you need to know an angle measure. Specifically, you don't have to know a single angle measure to use any of these formulas. They're based solely on the side lengths here. So you can get these formulas just by manipulating and putting in terms of the cosine with these formulas. This is just me pre-writing them for you, that this is the other version that you would have to use. And it's essentially, if I'm matching them up, that this was cosine A and this was side length A, all I had to do was isolate this cosine A. It's something you could do on the fly if needed, but it's helpful to have all of them written down just there with no mistakes made in them and just easy to use. Okay, so that is how we'll use them. There's 2 basic cases that we use law of cosine for. The first case is all side lengths. So if you could see, if I'm given all side lengths, I want to jump over to all of these 3 formulas to find some angle measures. Let's say I was given 1 angle measure, 2 side lengths. What I would have to do, if those weren't a matching pair, say the angle measure and the side length were not a corresponding pair, then I would have to say, yep, I have to use law of cosine, and it's going to be one of these, because I'm going to need to find another side length in order to either use law of sine or continue on with law of cosine. Okay, so we're going to first start out I'm just going to move my screen up a little bit with this example where we are starting out with 3 angle measures, or sorry, 3 side lengths, not angle measures. So clearly these 3 formulas are not going to matter to me right now. So I'm going to erase all of them. What will matter is all 3 of these formulas that I need with angle measures. So I'm going to try to draw this triangle out to the best of my ability. Okay, this is A, B, C, little a, little b, little c. Then we label our actual values. A is 8, B is 19, C is 14. So we do try to start with the largest angle first. And you might say, well, how am I going to know which one's the largest? Because I never draw these triangles to scale and they always look a little bit gross. And you can't base off of what it looks like and how I drew this. It has to be off of facts and measurements. So your largest angle will always be across from your largest side length. So here, that's going to be the hypotenuse. Largest side length is 19. So B will be my largest angle measure. So I'm going to start by finding angle measure B. In order to do that, I have to use this cosine B formula right here. That cosine B equals A squared plus C squared minus B squared all over 2AC. So let's go fill in the pieces that we know, and that's all of them besides my B measure or my angle. My A is 8 squared plus 14 squared minus 19 squared, all over 2 times 8 times 14. Okay, so always remember, try to put that calculator in degree mode. And if it's your own, you likely haven't changed it, but if it's one of mine, who knows who's changed it. So always go back through and check, is your calculator in degree mode? Then you can go ahead and plug and chug this. I would keep in mind you're going to want parentheses around your numerator and denominator. So when finding this, 8 squared plus 14 squared minus 19 squared, all divided by 2 times 8 times 14. I am getting a cosine B of negative 0.45. Okay, so I do sometimes just cut off these decimals, but you can always round them. I try to not round them a ton, because then you're going to get slightly inaccurate angle measures by the end of this. So I solved for cosine B, but I need my B angle measure, not cosine B. To get rid of a cosine, you cannot subtract it and you cannot divide it. You're going to have to invert it. So I have to take inverse cosine on both sides. Here it's canceling to just leave me with B. On this side, I get cosine inverse negative 0.45. So the way we put this in our calculators is we have to go to the second button and then down to the cosine button. And then go ahead and type in negative 0.45 and enter, which will get me a B value of 116.74 degrees. I'll come record that up here. Okay, 116.74 degrees. Again, always finding that largest angle first to begin with. All right, from here, you have a lot of different options. You could continue on with log cosine, doesn't matter to me whatsoever. Or you could revert back to log sine. Either one's fine with me. You could go back to saying, okay, I know my sine of B and my B value, but I don't know my sine of A, and I do know my A. So you could go use log sine with that formula, solve for it, and keep going. Just for the sake of practicing log cosine a little bit more, I'm going to go ahead and stick with log cosine and say, let's find cosine A, for no reason other than I just wanted to get you more practice with log cosine. If you want to use log sine, please be my guest. So cosine A is b squared plus c squared minus a squared all over 2bc. So filling in what I know my b squared is 19 and 14 and 8 and 2 times 19 times 14. Again, parentheses around all of it, numerator and denominator. Putting this into my calculator, 19 squared plus 14 squared minus 8 squared divided by 2 times 19 times 14. And that one is giving me there we go. Okay, sorry, I took the wrong first. Okay, so I'm coming down to a cosine A equals 0.926. We'll just say 67. Okay, so then again, to get rid of cosine, we have to cosine inverse. It just looks like a cosine to the -1 power. Okay, so cancels this cosine, giving me A equals, when you put that into your calculator, you should be getting about 22.075. So 22.075. At this step, I could do 3 things. One's the one I definitely want you to do. The other 2 are much harder than it needs to be. I could use law of sine and keep going to find my angle measure C. I could use law of cosine, again, to find my angle measure C. Or I can remember that triangles add up to 180. So take 180 minus the 2 angles I already have added up to get my actual C value. Okay, so if I do that, if I add up my 22.075 plus 116.74 and subtract 180, you will get a C value of 41.185. Okay, if you are getting any small off decimal, like if you were getting like 45, you probably are doing something wrong. If you're getting 41.7 or 41.02, that's fine. You can get slightly different decimals. It's just going to depend on how you rounded, maybe how you didn't round. Maybe you went a couple decimal point or decimal places further. Maybe you went a couple decimal places less. You might have different decimals in that sense, but you'll have essentially the same whole number there. Okay, so that is that example. Solving to get all those angles with only given sine measures. So the next one is going to be a little bit different. The second case you will see with this, and the only other case. You are given B, A, and C. So B is 9, little b is 9. A is 25 degrees, and C is 12. So let me attempt to draw this out again. That was probably bad, but that's okay. Again, totally not accurate. So what I have is my angle measure A, which is 25. I have C, which is 12, and B, which is 9. So the first step is, do I have enough information to use law of sine? So I usually try to just start with law of sine instead. Since I do not have enough information to start off with law of sine, I have to use law of cosine. If you are a law of sine junkie and you know that you're going to want to end up using law of sine, there's one specific value I'm going to go try to find here. And I'm not going to be able, I'm not going to be able to use my formulas over here yet, because all of these are dependent on knowing all three side lengths. I don't know all three side lengths. I only know two of them. So I'm going to have to start out with one of my side length formulas, one that starts with the a squared, b squared, or c squared. Because I know my angle measure A, I'm going to start out with side length A. That's going to give me that matching pair that I want, side length and angle measure. And that was b squared plus c squared minus 2bc cosine A. So if we plug and chug a little bit of this, I get a squared equals 9 squared plus 12 squared minus 2 times 9 times 12 times cosine 25. If we put all of this into our calculator, 9 squared plus 12 squared minus 2 times 9 times 12 times cosine of 25. I'm getting 29.238. 29.238. But this is an a squared value. I don't have my a value. I don't want to know what my a squared is. I want to know my a. To get rid of that square, you have to take the square root of both sides. Because this is a measurement, there's not going to be a negative version of this. Usually when we take the square root, we put a plus or minus symbol in here. It's a measurement, so we won't do plus or minus. We're only going to take the positive version of it. So again, square root of the answer you just got. And I have 5.41. Let's just do that, 5.41. And that is my A value, my A side length. Okay, from here, again, doesn't matter. You could try now to say, well, I'm going to find my next side length, which would be C, to go ahead and, or angle measure, to do log cosine length. I am going to go ahead and start with my, what do I want to start with? I want to, I forgot, this one's gonna end up with a couple of cases. So I am going to start. Yeah, that's gonna have to be where we start. Let's start with doing cosine of C. So log cosine for angle measure C. Cosine C equals a squared plus b squared minus c squared all over 2ab. Fill in my missing pieces. And I get 5.41 squared plus 9 squared minus 12 squared all over 2 times 5.41 times 9. All right, into the calculator. Okay, so again, why did I start with C? And I can't remember if I explained this already or not. But I'm starting with C because the fact that C is my largest side, so that's gonna be my largest angle measure. We wanna start with our largest side to find our largest angle measure. So because that's gonna be my motive here, I have to say, well, that's gonna be my next thing that I find. Given that I am getting that cosine C equals negative 0.347, and that when I cosine inverse that, I'm getting C equals 110 degrees. I think I am doing everything right. Okay, what do I say, think? There are times when you are solving these where you might end up trying to solve for the wrong angle first, and I say wrong angle. Had I went for angle measure B first, I might have ended up in a place where you get two different cases, and where you say, oh no, I'm getting B as my largest angle, my largest angle measure, and that's not what you're supposed to be getting. So being very careful to make sure that you're trying to find that largest angle measure first, and then following through with the rest of them. So here I'm getting 110 for C, and that sounds perfect, because now when I go to solve for B, by just doing 180 minus 25 plus 110 plus 26, you will then get your B measure. Oops, sorry. Giving you 44.73. That doesn't sound right. Oh, it does. 44.73 as your angle B. Okay, so huge things here. Try to stick with finding that largest angle first. If you like law of cosine, stick with law of cosine. If you like to switch back to law of sine, be my guest, feel free to. I typically like to stick with law of cosine once we're kind of into it. It's a way to ensure that you're finding that largest angle first, and you're always going to have those formulas provided for you on a note card or something. You can always write them down and use them on a test. So I typically stick with law of cosine once I'm using it, but you can always revert back to whatever you're most comfortable with. Okay, so those are the two cases that you'll see with this one.